I propose here in this short video the explanation of the solution of the exercise best burger. So first of all, I have to store all the value describing all the different ingredients, their fat, salt, and so on. So this is the goal of this first parameter. This is not a variable, it's just a parameter, and this parameter is called ingredients. This parameter is composed by int numbers, okay, and this matrix has this size. And here you can see all the different parameters you have in the statement. This parameter and these values are mandatory to perform the evaluation of the cost of your burger, the fat of your burger, and so on. So this is not a variable because the goal of the solver is not to give value to this thing. The goal of your system is just to find the best configuration of burger. So that's why we have here the real and the only the key variable of this problem. So this variable is called composition, and here we just have an array of only one dimension, so this is a list of 8 elements because you have 8 ingredients, and all the different values of this self of this list can evolve from 1 included to 5 included. So these values are the one expressed in the statement of the best burger exercise. After that, I use another variable, which is an integer, and this integer is named total cost, and I use a sum aggregator to evaluate the cost of this burger. And the cost of the burger is just the cost of each ingredient multiplied by the number of ingredients I use in the burger. So this is what I have here. So I focus on the composition of the I element, and I consider the cost in the fourth column of the descriptive parameter of each ingredient to evaluate the sum. Why I define this? Because this is very important in the final step when you will select the most costly burger, which is the criteria of best burger. Regarding now the other constraints, so here the two constraints here are mandatory to express that the constraint explained in the statement that you say we need the same amount of lettuce and ketchup, and we say we need the same amount of pickles than tomato. So that's why you have here a constraint of the number of lettuce and tomato and the number of pickle and tomato. The other constraints here are structured exactly in the same manner because they are expressing exactly the same kind of constraints. These kind of constraints are the ones that want to bundle the fat, the sodium, the salt, and the calorie of the burger. And to evaluate these three characteristics is exactly the same thing than evaluate the cost characteristics. That to say, you just have to multiply the configuration of the burger with the different information you have regarding the salt, regarding the fat, and regarding the calories. And as the end, you compare the sum with the bundle expressed by the customers. So here we have the three main constraints. And after that, because here I want to find the best burger, I use solve maximize total cost. So I want to select among all the solutions satisfying the problem, the one having the maximum cost. Here I just express, just to show you the way of using the output function. So it's a list of string, okay? And because total cost is not a string, it's a float number. No, sorry, it's not a float number. It's an int number, sorry. So because this total cost is an int number and not a string, I need to use show to convert the type of this variable. If I run this, you can check that the best burger costs 280 cents. And you have here the amount of sodium, fat, and calories. And you can see that the configuration of this burger is this one. And if I want to check the, not the best one, but if I want to find all the solutions satisfying, I can here change this and run. And here you can see all the different solutions available. There are a lot. Okay. So that was the final exercise I want you to explain. Now I consider that you master enough Minizinc to continue some other exercise or to perform the last project. Bye.